Hello everyone. In this video, I want to take a look at some special solution sets for when we're solving linear equations. So we've seen lots of equations that when we solve it, we get a specific value for the variable. So let's say we're solving for x, we go through the whole process, and after we're done, we get x is equal to one number. Well, that's not always the case. There's actually two other possibilities that we can end up with for our solution. I'd like to illustrate those with a couple examples. So let's go through these and then we'll talk about the solutions when we get there. So the first one, I have 2x plus 6 is equal to 2 times x plus 4. So let's start off by solving this, or we'll try to solve it the normal way. So we'll simplify both sides. So 2x plus 6, and then on the right side we'll distribute the 2. So 2x, and then 4 times 2, we get 8. I want to group up my variable terms, so I'm going to subtract 2x from both sides. And maybe I'll subtract 6 right away from both sides as well. And if I do that, 2x minus 2x, I end up with 0. And then on the other side, 8 minus 6, I end up with 2. So my variable terms completely canceled out. And what I end up with here, this is a false statement. So 2 is never equal to 0. So because of that, my solution set, this is no solutions. I have a couple ways I can represent no solutions. In set notation, I use fancy brackets to indicate a set, but this set has nothing in it. Or I can use the empty set notation, which is a circle with a line through it, like this. Now what this represents, these are linear equations, and if I end up with no solutions, I'm basically talking about parallel lines. So these are lines that they never intersect, so they have nothing in common, so they don't have any solutions. So that's one possibility. Now let's take a look at our second example to see the other possibility. So again, let's just try and solve this as normal. So I'm going to simplify the right side, distribute the 6. So this is going to be 6x plus 6, and then I have a minus 2x. Combining like terms, we have 4x plus 6. And grouping up our variable terms, I'm going to subtract 4x from both sides. Maybe I'll subtract 6 right away. And in this case, all of that's going to give me 0. And on the other side, I also end up with 0. So in this case, I end up with an always true statement. 0 is always equal to 0. So this is never false. For our solutions, this means I have infinite solutions. In other words, I can plug in any value for x that I want, and I will end up with a statement that's true. So another way I can say this is x is a real number. So in set notation, I would say x, and then this straight line means such that x is a real number. And the other way that I can represent this, notation, the symbol that we use for real numbers, is this double barred R. So capital R with an extra bar like that. But we have infinitely many solutions. So the two possibilities again, no solutions. When I'm trying to solve, I end up with a false statement. So 0 equals 2. That's never true, right? So I don't have any variables there. For infinite solutions, again, my variables cancel out. But now I'm left with an always true statement. Something like 0 is equal to 0. Or 6 is equal to 6. And that gives me infinite solutions or all real numbers.